Our approach involves creating redundant systems and failover mechanisms to ensure minimal downtime. We focus also on real-time data replication and automatic failover to ensure that if one system goes down, then the other system immediately takes its place without disrupting the application's performance.
Hi, this is your host Swapnil Bhartiya and welcome to TFR Let's Talk. Today we have with us once again Dave Bermingham, Director of Customer Success at SIOS Technology. Dave, it's great to have you back on the show.
Yeah, it's good to be back. Thanks for having me once again as well.
Today we are going to talk about ensuring high availability for critical applications that support edge computing. When we think of edge computing, we think of various devices that bring computing processes closer to users. What are some examples of these devices and what improvements can they make to how a business operates?
Yeah, it's true. And, people do have different, ideas when they think about edge computing. And it does include a wide range of equipment and devices. So you think about, sensors in manufacturing plants or surveillance cameras and security systems, wearables in healthcare. If you are, the new Apple Watch, right, with the pulse ox, all those things are local, collecting data locally. Autonomous vehicles, right? They have the computer right in the vehicle that's making real-time decisions for them. It's not decisions made back in the data center. So these devices will collect and process that data locally, which reduces the latency that enables the real-time decision making. For businesses, this means faster response times and improved operational efficiency with the ability to perform complex analysis on site. So again, for an example would be in the manufacturing setting, those edge devices can detect anomalies in real time and prevent costly equipment failures or significantly improve the uptime and productivity.
What are some examples of these devices and what improvements can they make to how a business operates?
Edge devices include a wide range of equipment like sensors in manufacturing plants or surveillance cameras in security systems, wearables in healthcare, and autonomous vehicles will have edge devices right in the vehicle, helping make real-time decisions. So these devices collect and process data locally, which can reduce the latency, which enables real-time decision making. So for businesses, this means faster response times and improved operational efficiency, and it gives them the ability to perform complex analysis on site. So, for example, in manufacturing, edge devices can detect anomalies in real time and prevent costly equipment failures, significantly improving uptime and productivity.
And if you look at the importance of these devices, are businesses doing enough to ensure the reliability and availability of edge computing devices along with the backend systems that they often refer to?
Businesses will recognize the importance of edge computing and to ensure the reliability and availability of these devices and their backend systems, but it is an ongoing challenge. It's just about deploying the devices, but also about maintaining consistent connectivity, managing the data they generate, and ensuring they're resilient against failures. But businesses, need to invest more in robust HA solutions and strategies to minimize downtime and maintain continuous operations, especially as the devices and service providers and these devices become more integral to their operations. We all probably heard a few years ago about, when people couldn't get into their homes because their edge devices, the system was offline and they were actually locked out. So you could see that the importance of maintaining uptime and ensuring high availability across all the components that make up that that service, that the connectivity, the back end connection, the database, and even the local devices are critical for the success of the company.
Let's now talk about how does SIOS help organizations in achieving high availability in the backend system, which directly impacts the performance and reliability of edge computing deployments.
We're all about high availability. So we specialize in providing high availability and disaster recovery solutions. And very often we find ourselves being deployed in support of edge devices or on edge devices themselves. Our approach involves creating redundant systems and failover mechanisms to ensure minimal downtime. We focus also on real-time data replication and automatic failover to ensure that if one system goes down, then the other system immediately takes its place without disrupting the application's performance. So this, for the end user, means continuous operation and data integrity, which is going to be crucial for edge computing environments where that real-time data analysis is crucial.
Can you share some best practices with businesses to create redundant systems, implement failover mechanism, and ensure continuous monitoring and management of critical resources? And it will be great if you can highlight a use case there.
It's just like any other systems and HA in general. So some of the best practices apply across edge devices as well. One, you have to conduct regular risk assessments, and so you have to really look at all the components that make up the service that the edge device is supporting and see where your risk lies, and then making sure that you have redundancies in place for all those potential single points of failures. So implementing, again, those, the robust failover solutions and disaster recovery strategies is not always about HA. If you think about entire data center supporting a system, you need to have a robust disaster recovery strategy as well. And, with both of those, that involves continuous monitoring and proactive maintenance. So once you've implemented your system, you need to maintain it as well. So that's keeping up to date with latest releases, with patching security risk, and ensuring that it's that your system is going to stay online and also be secure. And then it's essential to test these systems. So regular DR testing to ensure that when and if you have a disaster, that you're going to be able to recover as expected. So, by implementing these redundant systems and failover mechanisms, we can ensure that the systems are going to work without downtime. So making sure that they are going to be available when needed. So I'll give you an example. Something I was involved with was an oil. There's oil wells out in off the coast of Norway, and each oil well had a redundant pair of servers that were continuously collecting data based upon what their sensors were collecting, and that data was then used to determine what was going to happen next with that drilling. Do we need to drill faster, slower, deeper? I mean, I don't know all the the mechanics of what makes the optimal drilling, but having that local system on each oil well itself in the middle of the ocean, you can imagine the harsh environment that these servers were put in. So having redundancy was critical to make sure that they were able to maintain operations and to drill efficiently without any downtime. So that's just one example of really a kind of a local edge solution that we were able to ensure the availability of that.
Dave, thank you so much for taking time out today and talk about this topic. And as usual, I look forward to talk to you again soon. Thank you.
All right. Thank you, Swap.